Look at your hand right now. That skin covering you carries a story millions of years in the making. And the most surprising part? The answer isn't what most people think. Every single human being on this planet started out with the same skin color. Every single one. Dark skin, deep brown, almost black. Not because of geography, not because of chance, because survival demanded it. Our story begins in Africa, under a sun that shows no mercy. 300,000 years ago, all Homo sapiens walked the same land. They all looked alike, and their skin was a precise biological machine. The largest organ in the human body, a shield, a sensor, a thermal regulator, a barrier between life and death. Every day, the sun fired ultraviolet radiation at that skin like a relentless army of invisible arrows. UV rays penetrate cells. They reach the DNA inside. They break molecular bonds. And when those bonds break in the wrong place, something terrifying begins. Uncontrolled cell growth. Cancer. But the skin had its own defense system. A molecule that changes everything. Melanin. Melanin is like a shield system built directly into the skin. Every cell comes with its own personal guard. The more melanin, the more shields. The more shields, the better the protection against UV rays. Under the equatorial African sun, dark skin wasn't a feature. It was a survival requirement. The evolution algorithm was brutal and precise. Those with more melanin lived longer, had more children, passed on their genes. Those with less melanin died earlier, had fewer children. The equation was simple, but UV radiation had a second weapon, one far more insidious. It didn't just attack the skin, it attacked something inside the blood. There's a molecule called folate, vitamin B9, that flows through every human bloodstream doing essential repair work. UV rays penetrate beyond the skin and destroy it. And here is where the story becomes deeply human. Because what happens when folate levels drop during pregnancy is one of the most heartbreaking things biology can do. The embryo's neural tube, the structure that will become the brain and spinal cord, needs folate to close properly in the first weeks of development. Without it, it doesn't close. The consequences are severe: paralysis, cognitive damage, death. If this story moves you, if you feel how extraordinary it is that something as simple as skin color is connected to whether a child is born healthy, share this video. You could be giving someone else the chance to understand where they really come from. A lighter-skinned pregnant woman in equatorial Africa was at a biological disadvantage. More UV penetrating her skin meant more folate destroyed in her blood. Fewer chances of a healthy pregnancy. The evolution algorithm registered this, without emotion, without judgment. And gradually, over thousands of generations, dark skin became the signature of the equatorial human. Then, something happened. Around 70,000 years ago, some groups began to leave Africa, not all at once, in waves, in small bands. They carried dark skin with them, and they walked north. Generation after generation, they moved further from the equator. The landscapes changed, the temperatures dropped, the skies turned gray, and something fundamental changed: the sun. Not the same sun as in Africa. In the northern latitudes, sunlight arrives at an oblique angle. The atmosphere absorbs most of the UV radiation before it ever reaches the ground. The same sun, but weaker, much weaker. The melanin that had been a lifesaver in Africa suddenly became a problem. Because UV radiation does something else besides damage cells. It also creates something essential: vitamin D. When UVB rays hit a molecule in the skin called 7-dehydrocholesterol, a chemical reaction is triggered. The molecule transforms. Vitamin D is born. The skin is literally a solar factory. It captures energy from the sun and converts it into one of the most important compounds the human body needs: and you can barely get it from food. Without vitamin D, the body begins to fail in ways that are slow, silent, and devastating. The intestine loses the ability to absorb calcium. Bones stop receiving the mineral they need. They soften. In children, the legs begin to bow under their own weight. The skull deforms. The spine curves. In women, the pelvis narrows. And a narrow pelvis in childbirth, without modern medicine, was often fatal for both mother and child. This is not a metaphor. This was a reality that killed people. A dark-skinned person in northern latitudes produced almost no vitamin D. Their melanin shields, designed to block UV rays, couldn't tell the difference between a dangerous ray and a useful one. They blocked everything, including the ray that kept them alive. The evolution algorithm observed this and began making random notes in the DNA. Spontaneous mutations reducing melanin production appeared here and there. In Africa, these mutations disappeared almost immediately. They were eliminated by natural selection. Less melanin under the equatorial sun meant more UV damage, less folate, fewer healthy pregnancies. But in the north, something different happened. A lighter-skinned person produced slightly more vitamin D. Their bones were slightly stronger. Their children were slightly more likely to survive. The evolution algorithm pressed the green button. Generation after generation, lighter skin spread through northern populations. Slowly, over thousands of years. Or so scientists thought. Because recent genetic science overturned something fundamental. The lightening of European skin didn't happen gradually over 40,000 years. It happened recently, explosively. Hunter-gatherers who lived in Europe just 8,000 years ago still had dark skin. Some had dark skin and blue eyes, a combination we find striking today, but which was completely normal then. Cheddar Man, the oldest, nearly complete human skeleton found in Great Britain, dating to around 10,000 years ago, had dark to medium dark skin and striking blue eyes. He was not an exception. He was the norm. Lighter skin, the very light skin we associate today with Northern Europe, appears in the genetic record only in the last 6,000 to 8,000 years. That's less than 3% of our species' entire history. What happened? Agriculture happened. Around 8,000 to 10,000 years ago, Neolithic farmers from the Middle East began spreading into Europe. They brought with them a new way of eating. Before agriculture, hunter-gatherers consumed a varied diet rich in animal products: fish, liver, shellfish, eggs, foods that contain significant amounts of vitamin D. Neolithic farmers ate primarily grains: wheat, barley, rye, oats. Cereals contain almost no vitamin D. The dietary source of the vitamin almost disappeared overnight. Now the only way to obtain it was from the sun hitting the skin. And in the cloudy skies of Northern Europe, with little UV radiation available, and with dark skin blocking what little there was, the evolutionary pressure became enormous. A scattered hunter-gatherer population of 50 people spreads a beneficial mutation slowly, over hundreds of generations. A dense network of interconnected agricultural villages. The mutation can spread in just a few dozen generations. The skin lightened, fast. And it didn't happen just once. Genetic science reveals something astonishing. Populations in East Asia and populations in Europe developed lighter skin independently, through different genes, different mutations, different molecular pathways, the same result. This is what biologists call convergent evolution. Two separate populations, solving the same biological problem, arriving at the same solution by completely different routes. The sun demanded an adaptation. Two different civilizations answered the call in two different ways, and nature approved both. And blue eyes? Here the story gets even stranger. All early humans had brown eyes. Brown is the default. It comes from high concentrations of melanin in the iris. Blue eyes don't have more melanin of a different color. They have less melanin. And every single blue-eyed person on the planet today carries the same mutation. A single genetic change in a single individual, somewhere near the Black Sea, between 6,000 and 10,000 years ago. Think about that for a moment. Blue eyes are younger than the wheel, younger than writing, younger than the pyramids. A color we consider ancient, timeless, almost mythological, is one of the most recent biological inventions our species has made. The evolution of human skin color is still happening. It never stopped. But today, we live in a world where technology buffers many of the selective pressures our ancestors faced. Supplements, sunscreen, heated homes, global food distribution. The evolution algorithm continues operating in the background. It just has a much harder job now. And understanding all of this forces us to confront something uncomfortable. The hierarchies built on skin color throughout human history were never biologically justified. The differences between human skin tones are not profound. They are a calibration, a biological dial adjusted to the distance from the sun. A dark-skinned person in equatorial Africa is perfectly calibrated for their environment. A light-skinned person in Northern Europe is perfectly calibrated for theirs. Put a light-skinned person under the equatorial sun without protection, and watch what the UV radiation does to their skin, their folate, their DNA. They are not superior. They are adapted to a different sun. The original skin, the default setting of our species, the skin that all Homo sapiens carried for the first 97% of our history, was dark. Everything else is an adaptation, a variation on the same theme. The sun doesn't choose sides. It radiates equally on everyone. It was biology, blind, indifferent, mathematical, that shaped us. And we shaped ourselves. Out of Africa, through ice and snow and cold gray light, through wheat fields and fishing villages and ancient forests, through hundreds of thousands of years of sunrises, we were all, once, the same color. We all carry the same journey in our skin. If this story changed the way you see something, yourself, someone else, a random stranger, leave a comment. Tell me what you're thinking. Because the most extraordinary thing isn't the science. It's that each of us carries this entire history written in our skin, every single day.